All right, class, welcome to Lab 7, Week 7. This is going to be your video for Part 1 of our lab. We're going to start out with doing higher order factoring. This is factoring that has a higher degree, but we're going to work it exactly like we would any of our regular factoring. Like always, we start with our GCF first. So if we look at A, we notice that we have an x to the fifth, x cubed, and a 6x, so we know that they all have an x in common. So we're going to pull that x out. Sorry, guys. So we pull that x out, and we're left with x to the fourth plus x squared minus 6. Just like we would any other trinomial, we're going to say what times what gives us -6, but adds to be a positive 1. If we know our factors, we know that it has to be a 2 and a 3, and for it to be a positive 1, it has to be a positive 3, -2. The only thing that is different is when I go to create my factors, I am going to start my first one, right? I know that I have to multiply the first term times the first term, so they have to equal an x to the fourth. So it has to equal an x squared plus 3 and an x squared minus 2, and that's it. All right, looking at B. Again, the first thing that I always look for is a GCF. So looking at it, I have a 2, 2, and a 40, so I know I'm going to pull a 2 out. So I'm left with an x to the fourth minus x squared minus 20. Again, I work it like I would any other factor or trinomial, and I say what times what gives me a -20, but adds in a way to give me a -1. If I know my factors for 20, I know it has to be a 5 and a 4, and it has to be a -5, positive 4. And again, when I go to put it back into my factors, I know it's going to be an x squared minus 5 and x squared plus 4. Now, usually whenever we're looking with factors that have x squareds, we also need to look at them and verify, can I factor it further? Is it a difference of squares? And in this case, looking at it, I do not have a difference of squares. You may try to do that with your x squared plus 4, but you can't, because you have to remember you cannot factor a sum of squares. So in this case, this is my final answer. All right, C. This is just a quartic. It has 4 terms, so we are going to take and group the first 2 and the last 2. And of course, we're going to pull out an x squared to make sure that we have, and then we're going to pull out a -25. All right, my x squared comes to the front, and I divide, and I get an x minus 4. Minus 25 comes out front, and I'm left with an x minus 4. All right, I'm going to factor them so that that's x squared minus 25, x squared minus 4. This is where I want to look at it and go, okay, can I factor anything further? And in this case, I can. I have an x squared minus 25. Can I take the square root of that 25? Yes, I can. So I know that it's going to be x minus 5, x plus 5. Sorry, that's not supposed to be a square there. Whoops. Whoops, whoops, whoops. What just happened? 25. Okay. Sorry, guys. And then that x minus 4 comes down. I can factor no further, so these are all 3 of my factors. Now, we're going to talk about going from our zeros and work the problem backwards to get our polynomial. So instead of being given, well, if I were to solve this, I would get an x equals plus or minus 5 and a 4, right? So this time, we're going to work our way back to the factors and then back to the polynomial. So that's what we're going to be doing for question number 2. So in this case, I say my 0 is -2 with a multiplicity of 2. So my x is a -2, and it has a multiplicity of 2. And then I have an x that is -1 with just a multiplicity of 1. And this degree 3, whenever I go and I get my final answer, it should be a polynomial with a degree of 3. So I have my zeros. I'm going to put them back into their factors. I know that if I move that 2 back to the other side, it would be an x plus 2. Because it has a multiplicity of 2, it's going to have an x plus 2 again. And then if I move that -1 to the other side, it would be an x plus 1. Now I know many of you would like to be done, but we are not done. We actually need to take this. Sorry, let me rewrite it up here. We're actually going to take this and we're going to multiply it. Now, I wish that I could tell you that there was some fancy way that we can multiply all 3 of these at exactly the same time, but we can't. So what we have to do is take and multiply the first 2 first, so that we get x squared plus 4x plus 4. And then we have our x plus 1. Now, anytime I'm doing trinomial multiplication, I like to use the box method. It is one of the easiest ones to keep up with and keep track of your math. So I'm going to create a box. All right, so I'm going to put my trinomial up top. I get an x squared, a positive 4x, and a positive 4. I keep the signs with the number. And then I have an x plus 1. So I'm going to multiply the first 2 terms to get an x cubed. I'm going to multiply x and 4x to get a 4x squared. And then an x times that positive 4 is just going to be a 4x. 1 times x squared is just x squared. 1 times 4x is 4x. And 1 times 4 is just 4. Now, the cool thing about using the box method, your like terms are always going to be diagonal of each other. So when we go to write our final answer, we get an f of x equals x cubed. X squared plus 4x squared is 5x squared. 4x plus 4x is 8x. And then that 4 is left behind all by himself. This is my final answer. And I have to verify. It said that I needed a degree of 3, and I have an x cubed for my first term, so I know I did it correctly. All right, we're going to do the same thing for part B. We have a 0 is 3, so we know x is 3. It has a multiplicity of 1, so it occurs once. It says we have a 0 is 2, so x is 2. This one actually occurs 3 times. It has a multiplicity of 3. And we're going to get a degree of 4 when it's all said and done. So of course I need to make sure that I create my factors first. So I have x, move that 3 to the other side and it becomes a -3. Move the 2 to the other side and I get a -2. But it occurs 3 times, so it's going to be x minus 2 again. And one more time so that I have 3 of them. Now, I wish that there was, again, some magical way to do this, but we have to do 2 binomials at a time. So we're going to do the first 2. And then we're going to do the second 2. So if I multiply my first 2, I'm going to end up with x squared minus 5x plus a 6. And if I multiply the second 2, I end up with an x squared minus 4x plus 4. Now, when we get into a trinomial times a trinomial, this is absolutely when I want to do my box method. You could go, oh, I'll multiply these two, these two, these two. If you start doing that, it'll get really confusing with those lines. So again, I just create a box. I create a big box. That way it's nice and pretty, and I have all kinds of space to work with. It doesn't matter which one goes where, so you're going to put x squared minus 5x positive 6. Draw my lines for that guy. And then I have my x squared negative 4x positive 4. Again, draw my lines. Now I can keep track of everything, and I should be able to add diagonally. So my first box, x squared times x squared, is x to the fourth. X squared minus 5x, or negative 5x, is going to be a negative 5x cubed. And then a positive 6x squared. This should be a negative 4x cubed. Negative 4, negative 5 is going to be a positive 20x squared. And a negative 24x. Let's see, then we have a positive 4x squared. Oops, sorry guys. Then a negative 20x and a positive 24 there at the end. So again, remember, we're going to add diagonally. So we should be able to take these two terms. All of my squares are going to go together. And then finally, my x's are going to go together. So I have my f of x equals, I have my x to the power of 4. Negative 4, negative 5 makes negative 9x cubed. 4 plus 20 is 24. 24 plus 6 is 30x squared. Negative 20, negative 24, that makes a negative 44x, and then that 24 just goes at the end all by himself. And that's my final answer. Practicing the box method, if you've never used it before, you should be able to get plenty of practice as you start doing these more and more for this unit. Now we're going to move on to complex numbers. We've kind of already seen complex numbers, but now we're actually going to work with them with problems. So remember, if you're given a square root of a negative 1, we take that negative, pop it out, so that we can just take the square root of 1, which is just 1. So our answer is 1. If we were to have an I squared, all right, it would be kind of like saying square root of negative 1 times square root of negative 1, or you can just remember that the answer is I squared is negative 1. So A, again, I want to get rid of that negative, so I pop out the I, and I'm left with the square root of 1. I take the square root, and I get a plus or minus I as my answer. All right, now square root of negative 4. I pop out the I to get rid of the negative, but then I must take the square root of 4, which is 2. So my answer is going to be plus or minus 2I. Remember, I don't add the plus or minus until I take the square root. All right, C, I have the square root of negative 12. Pop out the I, and I get my square root of 12. And I have to break apart that 12, so I can do 3 times 4 is 12. So I know I can take the square root of 4, so I get a plus or minus, that's a 2I. That square root of 3 is remaining.